Tonight we're going to talk about independent and dependent events. Hopefully this should be a bit of review, but I'm going to ask you to fill in your note sheet on the page that talks about independent and dependent, and we'll do a little practice with finding the probability. So independent events are basically exactly as they imply. The occurrence of one event does not affect or have any bearing on the probability of another event. Some examples of this would be like tossing a coin. So if I flip a coin, a fair coin, and we're saying that heads and tails are equally likely to occur, it doesn't matter how many times I flip that coin, I always have the same probability of getting heads, which would be 1/2. Okay, the probability of independent events is the same as the probability of A and B, and that's equal to the probability of A occurring times the probability of B occurring. So if we take a look at the first exercise, I have a 6-sided cube, a number cube, if you will. It's labeled with the numbers 1, 2, 2, 3, 3, 3. 4 sides are red, 1 side is white, 1 side is yellow. What's the probability of tossing a 2 and then a 2? So we're considering a little bit like that counting principle that you reviewed for homework that was due for today. It's basically like getting a 2, getting a 2. Well, what's the probability of getting a 2? There's 2 out of 6. And then what's the probability of getting another 2? It's independent. It doesn't have any bearing on what happened in the first try. So we'd have 2 out of 6 again, which means our overall probability would be 4 out of 36. And this is the one time when you are not expected to reduce fractions. When you're talking about probability, since we're technically talking about 2 out of 6 events occurring, we can leave it in unreduced fraction form. Of course, you can reduce it if you prefer, but you can, without any penalty, leave it in the unreduced form. Okay, so I'm going to ask you to either pause the video now or come back and work on part B, and then also number 2, again, independent events. Okay. Next, we're going to review or talk about dependent events. And dependent events are, as they sort of imply, the occurrence of one event has some sort of effect on the probability of another. So a lot of times you can tell if you need the dependent event probability if you hear words like without replacement. Those are kind of keywords that can indicate that you have a dependence. So for example, if I have a bag that has 2 lemons and a lime, and I pull out a lemon first, then the probability of getting a lemon on the second try decreases because I've already picked out a lemon on the first. So that's kind of the idea of dependent events. And so with dependent events, we have something known as conditional probability. Conditional probability is the probability that some event B, given that A has already occurred. Okay. And conditional probability is written in probability of B given A. So this little line means given, sort of like such that when we were doing notation. Okay, so to determine the probability of dependent events, we're still going to multiply, but you have the probability of A, and then we have the probability of B given that A has already occurred. And we'll take a look at an example so that we can kind of clarify what exactly that means. So if we take a look at exercise 3, we have 2 number cubes, 1 red, 1 blue, and we're looking at the sample space for the outcomes when you roll two number cubes, okay? And we're considering the red cube showing a 6 and the sum is greater than 9, okay? So we're looking at two things. We're looking at the probability of getting a 6, and then we're going to be looking at the probability that the sum is greater than 9 given that a 6 has occurred. Now we know that these are dependent on each other because there's no way you could get a sum greater than 9 with only one number cube. So we have to have two of them. Okay, so if we look at our outcomes, what's the probability of getting a 6? Okay, so we're thinking about all the places where there is a 6 occurring, right? So we're looking for the red cube showing a 6, right? So red cube shows a 6. That's basically this entire bottom row, okay? So that means there's 6 out of 36 for that happening. Now, given this section that's highlighted, okay, given that, what's the probability that the sum is greater than 9? So we're kind of looking for only in this section of 6, which reduces our probability for the second piece, right? Given that we only have 6 places to choose from, what's the probability of a sum greater than 9? That would be the last 3 in that section. Okay, and then you would go ahead and multiply them. If you prefer, you could reduce them for multiplying, or you can just multiply across and leave it in that form, whatever's comfortable for you. So if I reduce that, remember cancel merely means reduce to 1. And so 3 goes into 36 12 times, so I have a probability of 1 out of 12. Okay, so again, I'm going to ask you to stop the video here, and I'd like you to try number 4, and then I'll just, or you can wait and then pause it after I go quickly through some information about a deck of cards, because a lot of people may not be familiar with how a deck of cards works. So just so you know, there's 52 cards. There are 4 suits. And the 4 suits each contain 13 cards. So we have 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Now in this category, hearts and diamonds, these are red cards, and spades and clubs are black cards. Okay, so that's kind of important for some of the things we'll be doing over the next couple of days. So if you could finish number 4 and number 5, and if you didn't do the ones on the front that I mentioned, please go ahead and finish those.